to a brand new video in this playlist. We are looking at continuous probability distribution. I hope that all the questions we solved under discrete probability distribution has been helpful. We'll be doing another continuous probability distribution, but before that, we want to look at the details and then whatever we need to know on continuous probability distribution. So then let's quickly go into it. So what are continuous distributions, or what are continuous probability distributions? So first of all, we said they are random variables that take what? Infinite values within a range. They take infinite values within a range. And we said they are variables that are usually measured. They are measured and then not counted. So examples are what? The height of people within a particular region, the time it takes to complete a task, and then the amount of rain in a city. All these are what? Modeled with continuous distribution because they take values within a range. All right. Okay. So let's look at some key characteristics of continuous distribution. So the first one, which is probability density function, PDF, probability density function. It describes the probability for range. You see, so the probability density function is simply a function that describes the likelihood of a random variable taking specific value. Right? Now you should know that for continuous variables, the probability that a variable takes an exact value is 0. But then, however, we calculate the probability of the variable, let's say, falling within a certain range. That is where we use the word probability density function. And the second key characteristic is the cumulative distributive function. We've done most of this in the discrete variables. So it simply gives what? The probability of being less than or equal to a value. Then we come to normal distribution. We will look at all these when solving the questions, and then the understanding will be made clear. So normal distribution, they are symmetric, they are defined by mean and then standard deviation. So they are the most commonly used probability distributions. So one key example of normal distribution is this we see over here. I have a graphical representation of it I'll be showing, but then before that, let me explain what they are. So a typical example of the normal distribution is the Gaussian distribution. We should know that they are symmetric and bell-shaped. Examples are the height of students, the speed of cars. So let me give you a diagram showing that. This we see here is a normal distribution. Alright? So as you can see, it is what? It is symmetric. You can see this line in between here. It divides it into two equal parts. And you see it looks like a bell. Yes, it looks like a bell. Okay. Now let's look at another example. So the next example of this continuous random variable we're looking at is what? The exponential distribution. The exponential distribution is also one interesting one that describes the time between events in a Poisson process. Right, so it is often used to model time or space between random events. An example is the time between customer arrivals and then the time between event and all that. Now this is a diagram showing how it also looks like. So if you see any of this diagram, then it is simply an exponential distribution. Unlike the normal one. Look at how the normal one look like. And then look at how the exponential also look like. Right? So you see there are two different things altogether. Then our very last one we'll be looking at is the uniform distribution. The uniform distribution. This is a diagram showing the uniform distribution. Now for the uniform distribution, every interval of the same length within the distribution range has the same probability. So if you are taking the interval from 0 here to 1, they all have the same probability. Example is rolling a fair die or picking a random number. If you play the die the probability of you getting a 1 is the same as the probability of getting a 2. Any face on the die, they are all the same. So within the range, all probabilities are what? The same. That is the uniform distribution. So these are examples of the distributions we will be working on in these continuous random variables. What are the key points we have spoken about? Continuous random variables have infinite values in a range, right? And then we have also said that the probability density function describes the likelihood within a range. And we've looked at some examples: the normal, the exponential, and then the uniform distributions. Stay tuned for more, even as we dive into these distributions.